little tutorial, a series of tutorials on programming in C. I'm doing this primarily for my own benefit, to give me something to do, to direct my mind in this task of learning, and I find that it's better that I pretend that I am teaching so that I will perfect my own understanding of the topic. So I am not a programmer. I've never programmed in any serious way in any language, and I figured where better to start than to start in the C language. Okay, so a few facts. It was created in 1972 by Ritchie of Bell Labs, working with Thomson while designing the Unix OS operating system. This is where you get the K and R version of C, which was prior to the standardized form known as ANSI C. That's when a group of people came together and decided on a certain set of rules by which C programming should be done, so as to eliminate a number of variables, such as people doing things in their own way, certain conflicting patterns of doing the same kind of thing. Having a standard is important. That way you can have a basic form of C language across all systems, executing the same sort of method behind the C language as compilers can behave more or less in the same way without conflicts across different systems. It's efficient, flexible, few restrictions for programmers. This lack of restriction does open the floodgates to errors that could be avoided in other languages, and as the old and perhaps trite adage goes, with great power, that is C, comes great responsibility on the part of the programmer. This is important and an additional reason why I'm personally making tutorials. It's not just for anybody out there, but for myself. Keep things organized and sensible. So the language of C is a compiled language. So it's an intermediary between machine code, which is the most basic code there is. All machine code is in zeros and ones, because that's how binary computation operates. You're operating off of ons and offs. So zeros and ones is machine language. Then you have compiled language. That's the intermediary. C is a compiled language, so it has the virtues of some of the virtues of an interpreted language. So it's more humanly, it has human qualities, symbolic, meaningful terms that a human being can understand and manipulate according to intent and will, like Fortran and Pascal. Then there are interpreted languages, which C is not, such as BASIC and Loco. These are more restrictive and more limited in what they can do, but they're also a great deal more friendly to the programmer, who may not require so much skill in doing certain other programs that are simple and not as feature-rich in terms of the complexities that compiled languages like C can permit. Okay, so we understand what C is. It's a compiled language. It was invented in 1972, standardized later, so that now we have ANSI C, just now referred to as C. So, there are a number of things to consider in designing C, and we will keep these things in our minds in general. So there are steps to programming in C. Steps to programming. First, we must define our objectives, what needs to be done, what will best make use of our computers as we program. We don't just program for the heck of it. We want to get something done. We want to get it done efficiently and as smartly as possible. We don't want to abuse or misuse or not use certain capacities that are available to us. Computers today are very powerful. We can get many things done. So we want to make use of that, and we have to consider, well, maybe we want to do something. What is that we want to do? That's where we have a program come into play, and that's what it's there for, to get something done. So then we've decided, well, we want to do this. Okay, we will begin with how will we design it, what is its interface. It has to interact, perhaps it has to interact with us at some level, maybe it does not. In any case, it at some point needs an interface. You have the user interact with it, or maybe you'll just have the program display information, and then you'll have to decide on the organization of the program. Things can get complicated, but that's why you determine in what ways you'll want it organized. See, you can allow a certain amount of modularity in design. Modularity is advantageous because that will permit you not only to keep a program better updated by, say, adding additional modules or deleting certain modules, but you can also modify them and keep track of what module does what in the program. You'll also have to decide on the target user in your interface. But more importantly, how long will the program take for you to complete? Having a certain design in mind will help you keep in mind what you're doing if the program takes a long time to design and implement. So we've decided on a design. It may or may not have a user. Then we begin coding. This is where you set out from pseudocode to writing working C code. It's better to have these steps separate because you don't want to have to think about the design as you're coding. It's humanly difficult to do two things at once, and especially when you're thinking in human terms and then trying to think in compiler terms. The two don't always interact in straightforward ways. You can always use a compiler, editor, text editor. Most compilers these days, they include a text editor, and thankfully the compiler we'll be using does, and that makes things very easy, more straightforward as we're translating our thoughts, our design elements into language. And as we code, it's a good idea, as you're writing the code, that you include commentary next to the code so that you understand, as well as others will understand later on, what the heck the program does as they're reading the source code. That is the non-compiled code. And then you simply, after you've coded it, you compile it. And as I said, we'll be using dev.c. Compilers will also help you fix the code. There are certain mistakes that can be made that are not necessarily fixable by the compiler itself. It will not detect all errors because there are many ways things can go wrong. Murphy's Law dictates that what can go wrong will go wrong, so it's best to keep things in check by documenting what does what. Testing and debugging, as you're coding the program, you can compile it, check it. If something goes wrong, go back to the compiler, say, okay, this does that, it's not exactly what I want, what can I change to make it behave in the way that I want it to. There are design errors, maybe there's a better way to organize the code. Perhaps we didn't consider that the user will input a number instead of a letter, and that introduces unexpected output that does not do anything useful as the program is designed to do. There are certain typographical errors that can be made, and sometimes that will introduce certain features that you don't want. So it's a good idea to learn very good habits early on, and at the end of this, it's really just repeating the process of coding and compiling and all that all over again. You want to keep the program up to date. Maybe you've thought of a better way to do something, so you want to perhaps start from scratch. You could even implement new features, adding additional features, adding longevity to the life of your program, its usefulness being extended. And as you do this, it's always a good idea to document those changes so that you can perhaps retain the older versions, but also keep new versions in a separate format. So a first program is never a 1.0, it's a 0.0 point whatever. No program starts, no draft is a final draft. program is infinitely modifiable, so keep that in mind. Nothing is technically a finished deal. You have programs these days that go on to version 9.0 and such. Well, it's never a final version. So that concludes the general format we have going here. C programming is preeminently useful in its core purpose. You want something done, want it done efficiently, quickly, and the programmer is meant to outline what that machine is to be doing. And so we have C language to do that.